Thank you everyone for joining the workshop today. This is Xiong again, and Professor Chen and I will share our knowledge about how to use open sources Visone and Gephi to carry out centrality and modularity analysis. During the following 80 minutes, we have two goals today. One is to refresh what we have learned about network analysis, and the other is to build up more knowledge about what we have learned. So many things you already know, and so today we invite you to practice together with us if you like to. And for the hands-on practice, we offer a step-by-step handout in Google folder. So if you have questions, you can check that handout first, or you can leave your question in the question box. And at the end of this workshop, we reserve 50 minutes for free self-practice and Q&A. So you have further questions, Professor Chen will be happy to provide you answer or suggestion. So first, let's start from data, but I think most of you already know, so I do not have to repeat myself. To put it in short, we use nodes as we use OBIS as nodes and use transfers as edges, and this is the weighted and directed network. Let me first introduce the ideas about modularity. So what is modularity for? Modularity is for us to detect to what extent node in the graph formed one or more communities and how those communities distribute in the network. So based on this understanding, what kind of research question we can ask and apply network modularity analysis to them. In our case today, we have hundreds of post-shipping records of selective officials. They are served in a special scholarly institute. This institute are regarded as a place to host promising officials for high-ranking court. So perhaps we can ask whether their careers can be classified into different stages, or what position would generally appear at each stages of their career. Also, usually which phase of their career did they serve in that special scholarly institute? Let's see what Gephi can help us for these questions. Now, let's first go to data preparation. Please open the file that we offer to you in the Google folder. That's a file named post-shifting row edges. It is a file end with .csv for its file extension. So what is .csv mean? It stands for common separated value. This is a format for use in Gephi and in Visone, and usually compatible for many other open sources. When you prepare your own data, beside on this special file format, you have several things should note. Yesterday, we learned a very professional way to prepare our data. That's to organize your data in WordPad. If you are a layman like me, perhaps you can try to organize your data in Excel spreadsheet. That will be much easier. When you doing so, you have to make sure you have two important columns. One is source column, the other is target column. So this source column and target column will form a link in the network. So for the rest, they are attributes. The attributes is some information attached to your data. In Gephi, you can use this information to fill out for further analysis. So in the future, if you want to prepare your own data, then make sure it looks like this. One thing you can also do is to number your links. However, it's fine not to do so. Then after you finish your preparation, do remember save your data as .csv file. So let's save our data. Okay. Next, we can move to Gephi. Okay. Next, we are going to import data into Gephi. So please start your Gephi first and select New Project. I already select, so I'm in Gephi now. So you see 3 buttons on the top. Please choose Data Laboratory. And can you see Workspace? And under it, you see a subtab Data Table. There is a toolbar. Click Import Data. Then choose the data we just saved. That's post-shifting row ages, and open it. So there is a window for a general CSV option pops out. Confirm that you select common as separated because our file is a CSV file. Here, our data are all ages, so choose age table for import as, and UTF-8 for character set. You see, okay. Here you see there are adjacent lists and metrics. So there are 2 other kinds of way to prepare your data to present notes and links, but this is not what we usually do. So choose H tables. Now click and check the preview. If you see everything's fine, click next. So subsequently, the system lists out all the columns header of our spreadsheet and led us to assign the data type of each column. Meanwhile, it's default source and target as what they are in our spreadsheet. So in our case today, we do numbered our ages, so we can choose it as integer. However, it is not used for calculation, so it's also fine if choose string for this column. And for the rest, they are all attributes and they are all words, so you choose string and finish. So now we see import report you already see yesterday. So Gephi tells us that it find parallel ages. So parallel ages refers to a situation that connection between a node pair appear for multiple times. So in network theory, the times of a connection between a particular pair of nodes occurs is regarded as the strength of that connection, namely how strong a connection is. That's the weight we mentioned earlier. Take our case, for example, today, a transfer happened between 2 particular offices, so say office A and B. No matter how many times this type of transfer happened, they are all treated as the same one. So ages can be taken into account, but you can also ignore that. So that's all depends on your research. In our case today, we have to take it on. So, but Gephi offers various kind of strategies to let you decide how to deal with these ages. So make sure that fits your research need. So today we choose song. And we add that into new workspace. Here you see that we have 329 nodes and 754 edges. This is not emerged yet. Later, after Gephi emerged, it will tell us how many individual unique edges we have. So click OK. Now you see we get a node table. And this is the link table we just import in Gephi. And you can see here we have weight. Gephi already count for us. I actually think this is a very useful function and useful tools. And if you only have parallel links data set and want to change it to weighted H table, I usually first run it in Gephi and then export that to other software for use. Okay. Okay, you see in the overview, we have 5 panels: appearances, layout, graph, connected, and filter. So in the context one, we have still 329 nodes, but now we only have 569 edges. That this is a directed graph, that a weighted directed graph that Gephi already done for us. Following is something that you already learned yesterday, is to give label to each node. So let us just done that quickly. You have to first move to nodes table, and then click copy data to other column and choose ID. And copy that to label. Then that will become nodes label for us. Okay, now let's move to overview. As already introduced, you see 5 panels, and we first go to layout. There's no fixed regulation for selecting proper layout. You can just explore each of them and see which matches your research topic the most. Usually, either Force Atlas or Force Atlas 2 is a very good place to start with. So keep in mind that there are some options of layouts are actually functional rather than theory-oriented. These functional layouts are contraction, extension, label, adjust, no overlap, rotate. So my suggestion is to run the theoretic oriented layout first, and then get a basic structure and modify the result with the functional layout. So let's choose Force Atlas first. If you click the information mark, it will briefly present an introduction, and by clicking each parameter, you can change relevant settings. There are also what you can try it out.
Should we pause here for a few minutes and let
Yes.
people ask questions?
Okay.
Right. I think it's a good time for everybody to try opening the data set in your Gephi. And if you have any questions, feel free to type those questions in the Q&A, and we will respond to those questions by typing the answers or answer live. Then after this few minutes, we will move on to the next stage of our workshop. We'll introduce some of the statistical and the visualization techniques, such as modularity analysis and the centrality calculations.
So is there any question?
So we have a question here, which says, I wonder in the layout running process, is it possible to reverse the process? No, there's no reverse button. There's no undo button in Gephi, but it doesn't matter because no matter what layout algorithm you choose, you don't change the data. You're only changing the algorithms that you use to define the layout. So what you can do is you can just go to a different layout option and run it. And if you want to be sure, there's a layout option called a random, and you can click on that, and that will rearrange the nodes in a random way so that you can start another algorithm from scratch. Another question, can you explain further on the different layouts? The different layouts, well, they're different. Now, we can actually give a little bit of a demonstration of the different layouts, right? Different layouts serve different purposes. Now, for example, we can choose the circular layout, and that we arrange the nodes in the circular way. Is there a circular layout? I believe there is. No?
No, but we
No,
have.
there's no circular layout. Okay. So
the circular layout is a plugin, so you have to install it with a plugin. Yeah.
I see. So, remember, Gephi is an open access software, so that's what's good about it. You can always, there are many people who develop different plugins for Gephi, and you can go to the tools, plugin, and find those plugins and install the plugins. That'll greatly extend the functions available in Gephi. At this moment, right, there are different kinds of layouts. The basic idea, for example, in Force Atlas, is that nodes with connections with each other, with strong connections with each other, will be pulled together, and nodes without connections to each other or weak connections to each other will be pushed apart. And there are different ways of arranging this. And the Yifan-Hu and the Yifan-Hu proportional, I think, are also very frequently used layout algorithms. Some of the other layout algorithms available in Gephi deal with different problems. For example, contraction and expansion allows you to contract or expand your Gephi graph to make it more visible. And there is another layout called no overlap, because very often you see these nodes are overlapping on each other, which makes it difficult for people to see. So no overlap will push the apart, so the layout will not be accurate. The graph you get is not accurate anymore, but it's more legible. So, so these are the different. I think if you use a plugin, you have more layout functions. That, for example, I remember it's a layout that can, which you can use to position your nodes according to the longitude and latitude of each node in the geographical, according to its geographical information. If your nodes have those geographical information, that I think was what Professor Peter Ball did yesterday with his Jinhua data set. So by the way, about the layout, if you're new to Gephi, you should recognize that when you run the different layout algorithms, even if you're choosing the same layout algorithm, you may end up with a different graph than what you see on on the screen. The reason is that it's the relative position of nodes in the graph that really matter. Right? The absolute position is a node in the upper left corner or a lower bottom corner of the graph. That doesn't matter. It's the relative position of the nodes to each other that really has sociological or structural meanings for us. So I wonder, next question, I was wondering what does the Force Atlas do and what does it do on the database? It doesn't do on the data set, okay? So it doesn't change the data. It only calculates the strength and weakness of the connections between each pair of the nodes and position them on the graph it's a visualization algorithm that does not change the underlying data. So what it does, as I said, is to pull strongly connected nodes together and to push weakly connected nodes apart. I have a question about exporting images. The images we see to be different from the preview and can actually be exported as a JPG. Yes, you can take a screenshot. Another possibility is to go to, you see the 3 tabs there, the overview, which is you're now at, the data laboratory, that's where we import the data. And there's a 3rd tab called a preview, which we don't have time to cover for today's workshop. But that's where you prepare the style of your nodes and graphs for exporting. You can change the color of the nodes. You need to redesignate the labels. So even if you see the labels in a certain fashion in the overview tab that you're on now, you will probably not see it in the preview tab. So you have to rearrange that. So that's usually the last stage of your work. Once you have something that you're sure that you want to publish, you go to preview and make certain adjustments. And there are many Gephi tutorials, video tutorials on YouTube, Bilibili if you're from China, and there is a 中文教程 by Liu Yong, a professor in China, and that's in Chinese. And there are some English language tutorials and textbooks on Gephi as well, so you can check them out. So our purpose here is to introduce you to Gephi and discuss the pitfalls that you may have encountered when using Gephi. So as Xiong Huei-Lan has explained earlier, when we import the data, right, there are many parameters that we need to set. We need to decide on whether this is a directed graph or not. What methods do we need to use to merge the edges? Should we sort of count the number of the edges and use them as the weights, or should we do something else? So that's the part we're going to be focusing on. How can I get a high resolution JPG of the image exactly the same with what you see in the overview? You go to preview, right? Huei-Lan may go to preview and show what's going on there on preview, right? It's just to give people a quick understanding, right? So you don't see anything, you have to click fresh. You have to click refresh to make it appear, right? So you see that the edges are curved, but you can change the presets from default up there, to something different. You can use straight edges, and you can use different labels, right? Here you see squares because you have to choose a certain font compatible with Chinese characters for these scripts to be correctly displayed. Yeah. I think a P-Ming Liu works, or the Microsoft Haiti, I think, J something, Microsoft Microsoft the P-Ming Chao also works, I think. That's the Japanese style. Does it work? Yes, it works. Yeah. So you have to choose a particular font that is compatible with East Asian scripts for these labels to show correctly if you have East Asian scripts as the labels. Our last question, how much data Gephi would take or handle? Any limits? Yeah, 700 rows is certainly not a problem. I think Marcus has been using Gephi also for visualizing his historical Buddhist networks. And I think in his data set, he has how many? Hundreds of thousands?
No, there are about 20,000 nodes in that Chinese data set. Gephi says it can cope with 2 million. I have seen 200,000 or so in another project once. I noticed that a lot of it depends on your CPU. So if you have, you need a very, very good computer to do more than 20,000 nodes and edges.
So Gephi is not your limit. The limit is your computer. Now remember, above a certain number of edges, you need to sort of reset the memory that you would need to want to allocate it to Gephi. So that's something that you need to do when you're handling large data sets. But usually Gephi handles big data sets pretty well for big data sets in the sense of historians work, right? Okay.
Yeah, there's also an article on that compares the largest visualization tools for social networks, and Gephi comes out pretty well. So it is a pretty stable tool for large networks.
Great. And actually, it's become better and better. I wonder whether there's a way to distinguish the different types of edges in the visualization. For example, in the network graph, or highlight the kinship relations in one color, friendship relations in a different color.
Yes, it's possible.
Yes, I think so, of course. If you go to appearance, for example, Huei-Lan, can we go to appearance? Then you see edges, right? And then we can go, and here you can partition, right? Partition the edges based on any number.
For example, we can use even character. So I have a regular appointment and concurrent appointment, or it changed its status. So that's a kind of, so you can apply the same thing to your friendship, a different kind of friendship relationship, and apply. Then the links will change color.
Yes. And another thing that Gephi can do is that you can import the entire data set into Gephi, and there's a filters function on you can see that on the right hand of the screen, and you can use that to filter it, right? So you can sort of see only part of that network. And then you can go to the data lab and copy and select all the things that you have filtered out and copy them into a new workspace. That in that case, you're creating a new data set for visualization, a subset of your data for visualization. I'm not sure we'll have time today for that. But now, in the interest of time, I think we should return to our main session, and I'll give the time to Huei-Lan. We'll continue her discussion of modularity analysis and the centrality measures.
Okay. Yesterday we already learned how to do the statistical calculation. So you see that's in your right hand side. You see the statistic panel, and then you can click modularity and run, and then the window pops out, ask us some question. So for this question, that is related to how you want your graph to be. First, do you want your this composition be more sophisticated? If so, then click randomize. Whether we use weighted links, yes. And for resolution, that's a bit tricky because sometimes you have tried it out whether the results give you more meaningful result. So usually we try from 1, and when you get the result, you can try higher or lower until you get meaningful result. So let's try it. Somehow it's quite slow. Anyway, so okay, good. Now we see the report, and it summarizes what we choose and give us results. So that now the modularity is 0.625. So usually modularity higher than 0.4 or above usually indicate the presence of a pronounced community structure in the network. So you will see there's a clear, distinct community separation in the network. And now the community number is 22. Okay, do remember this number. And at the bottom, it offers the algorithm and some information. If you are interested in resolution, then you can read this one. And here you can save your report or print it or save it as individual files. Okay, so also yesterday we learned how to visualize it. Let us try. And so color, partition, and modularity apply. So all the same like yesterday, but what different is, see the number, the percentage here, it represents each community occupied the proportion in the network. And here is the modularity class of each community. So if you want it appear in your graph, what can you do? You can do this. Click attribute on the bottom side. Now you see modularity class, click it. Okay. You may need some time. Notes. Okay. Oh yeah, now you see here's a number in the level of each node. So this is their modularity class. It's for you to observe the community distribution more easier. And based on the statistical figures here, we know that there are maybe 5 major community of offices in this post-shifting network. So this is what we haven't learned yesterday. So if you want to change color in a batch, then you can try this one, palette, and then you can choose color you want. And this can also let you choose how many colors in your combination you want to show in your graph. Okay. Now, any question about this?
I have a question, if I may.
Oh, yes.
Well done. So
yes, please.
A modularity group, this top modularity group, that would basically mean that these are offices which many people moved through on their way up. Is that correct?
Yes.
Okay, super, thanks.
Okay, good. Okay, now we are going to learn more about centrality. In the network theory, centrality is how well a node connects with other nodes in a graph, namely how central a node is among a number of nodes. This concept is the earliest idea that's used in social science to look into who is the star of the center of attention. In other words, who is the most popular among the group. However, centrality is not only useful for social relationship, but any kind of relations that we can find in our daily life between any entity. So various types of centrality measurements have been developed to investigate different kinds of relationship. Gephi done a well job to include most of these centrality measurements in his statistical and visualization tools. And we can briefly divide them into 2 categories. That's a degree-based centrality and non-degree-based centrality. So some scholars regard degree-based centrality as local centrality because it only concerns links, links of a node and its directly connected neighbors. So degree-based centrality represents the local significance of a node. On the other hand, non-degree-based centrality usually represents the overall structure significance, or you say that global centrality. There are 2 types of centrality, you can group them together. That's closeness-based centrality and betweenness centrality. These two we might learn yesterday. And eigenvector and centricity. So here I summarized about some information about degree-based centrality. As I say, it's only concerned each node's direct connection in its local environment. So anything that's indirect linked is not its concern. However, based on this idea, sometimes we have to distinguish the links move in and the links move out. Therefore, scholars separate them into in-degree and out-degree. However, as we explained earlier, weight, the strength of connection is also important. So something happened 100 times, it's meaningful. So it's different from 100 different kind of links. So you can see the summarize here, and degree-based centrality and weighted degree centrality, which one consider strength and which one not, and where you can find them in Gephi. And then, as I said, so non-degree-based centrality consider the structural role in the entire network. So we have this kind. So closeness centrality consider the distance from any other nodes in the graph, and betweenness centrality concerned to what extent it lies on the shortest path between other nodes. And centricity try to find which one or which ones are the absolute central nodes in the network. And eigenvector is very interesting. It cares about how important their neighbors are. So because each kind of centrality is devised for specific topic. So once scholars found that there are some problems they cannot solve, they will develop that kind of centrality further to meet their needs. So for example, closeness centrality, it cannot deal with a graph that within it nodes that are not well connected. So that's poor connected network. You can use harmonic closeness centrality. And then in our case, it seems that betweenness centrality is a wonderful tool for our case because we want to know which office is important for officials move upward to the top. However, most of centralities we can find in Gephi. There is a one. Oh, sorry, I forgot to say. So, however, not every officials can progress smoothly. Sometimes they will move in a relatively curved way to the top or fail on their way. So if in the real world it's not the shortest path they passed on, but sometimes the longer one or more possibility, then what should we do? So scholars develop another kind of betweenness centrality. It's a current flow centrality. So current flow centrality, it considers all kinds of routes between any pair of nodes, but it still gives more weight to the shorter one. So it matches the more close to the real world need. However, we cannot find this centrality statistical tools in Gephi. So what should we do? This story tells us that it's best to have more than one tools in your pocket. So now, today, we are going to learn how to use another tools that can give us current flow between the centrality figures. That's what we are going to do today, to learn how to use it visually. So if we want to use other software and we want to integrate our data in together with other figures we generate in Gephi, then we first have to import those data from Gephi and then calculate those data in the software can over the tools we want. Let's us export data from Gephi first. So let's go to data laboratory and then go to Node tab and click export table. Okay, so here we have options. Oh no, we need the H table, sorry. So we want to export the ages, weighted ages to Visone. Then first we choose age table and then we choose common. So, okay. Do remember to give correct name to your file. That's post shifting weighted age from Gephi. I think I did something wrong. Okay, let's do it again. So go to data laboratory and go to data table, go to age and export data. Go to option and choose data. Okay, and give name. Post shifting weighted age from Gephi. To make sure you save it as a CSV file and save. Okay. Oh, I have a question.
Yeah, I'll take care of that question.
Okay.
The question is about modularity analysis. You have to run it first. Yeah.
Okay. So we just keep moving.
Yeah, but I would like to emphasize, say one thing very quickly here, which is that we have different ways of calculating centrality measures in Gephi. Now, one thing it does is to calculate between the centrality, which Hong-Soo introduced yesterday as well. We can do that same thing here. The between the centrality measures to what extent a node plays a role in connecting other nodes in a network. When you try to do that in Gephi, Gephi asks you, is your data about directed edges, right? Which means a person is promoted from governor to member of the state council. That is different from a person who was in the state council and then was sent to a position to hold a position as a governor somewhere, right? So the direction matters. And it also asks you whether the edge weights matter. The number of instances of a transfer between two nodes, does that matter? Now, even though you choose, say yes to both questions when you're calculating between the centrality in Gephi, actually very misleadingly, neither is taken into account because of the particular way algorithm is for calculate between the centrality is implemented in Gephi. So in this network, Xiong Huei-Lan believes it is actually important for us to take the direction into account and for us to take the edge weight into account. And in order to take these factors into consideration when calculated between the centrality, we have to use Visone, which is a different program, which calculates a modified version of between the centrality called current flow between the centrality. And that's what we're doing here. We're exporting the data for Visone, where we will calculate this modified version of between the centrality and then import the data back into Gephi and integrate it with existing data in Gephi for visualization. Xiong Huei-Lan, please.
Okay, thank you. Now let us check whether we export the data correctly. Okay, if we want to read the file we just export, then we have to open a blank Excel spreadsheet and click data and get information from CSV file and choose the file we just saved and import. Now for the file origin, choose UTF-8, and for the separated, choose common. If you see there's something garbled, then maybe that's the encoding you choose to run. And if everything is right, correct, then import. Now you should see your links export correctly. So once you make sure that it's all fine, we can import this file into Visone. So start Visone and click the icon or folder on the second one from the right left-hand side. If you move your cursors on those icons, it will tell you what it's for. So you see the second one, open network from files. Click it. And then to open the file we just saved. Okay. The system asks us what kind of format it is at the CSV file. So it's scary. Now for the data format, it's link. And we do have headers, and this is directed edges. And this is the one mode network. What's one mode network refers to a network that is only one type of link in the graph. So a two mode link indicate the case that two kinds of relationship appears in one network. So let's say a person related to other person based on the events. So if a network wants to concurrently represent the relation between people and relation between people and events, then that will become a two mode. But now we only have one mode, so let's choose one mode. And the present file, you can choose Excel files, but you can also choose user-defined, because now Visone already detect that for us. But if you use that open source software, then you choose the third one. And we choose common as the delimiter, and for encoding the same, we choose UTF-8. Okay, so if the system did not choose the right option for you, you can first try detect, or you can choose yourself. Now this is the important part. We see here has status and types. So status means the function or the role of each column. So it is a link list. So we need a source as the nodes deliver links, and we need target as nodes receive links. So make sure that we choose source for the nodes who deliver links, and target receive links. If you choose everything correct, you will see like this. However, if you do not choose target and source column right, you will see graph like this. So nothing connected together. So in the future, when you are using Visone yourself, you find this, don't get panicked. You just to correct your source and target column. Okay, let's go back. Now we have data in Visone. So is everything okay so far? Let's move on centrality calculation. So first, you see analysis in your left-hand side panel. Because centrality are all index, so for the task, you choose indexing. If you want to do modularity, then modularity means grouping nodes in Visone. So you choose grouping and you can clustering them. But now we are doing centrality. And then choose node centrality. And then in the drop-down menu, you can choose current flow between the centrality. And Visone offers you two types of representation to show your current flow between the centrality. So percentage and standardized. So choose choose either that fits your research. And then here is a very useful function in Visone. You can decide to apply this setting you already choose in the current tab here. Or you can also apply this setting to all open networks. So if you have several different networks already opened in the other tabs, you can choose open network to other tabs. Then the statistical calculation you choose will apply to them all. So, but now we only one, so we choose this network. And you can't apply this calculation to this network in this tab, or you can let Visone to result in another new tab for the calculation you are going to do now. So now we first choose same tab and analyze. Nothing happened because it's only do calculation, not visualization. And then perhaps we can also do to do weighted degrees centrality. Where is it? So so then you choose degree or other in degree, out degree, then you can calculate. Okay. So once you choose any kind of degree centrality or weighted degree centrality, it will ask you whether you want the weighted be counted. If you want, then choose weight for link strength, then analyze. So now we are finished our calculation in Visone. Next is for visualization. So move to the tab next to analysis, you see visualization. So for category, we choose mapping because we want to give colors or size to nodes. And you can change the size, the color, and anything you can imagine. And let's use size, for example, now. And if you want to change the size proportionally according to the current flow between the centrality, then you choose nodes area. Be aware that the language Visone use is a little different from what we use in Gephi. So you can be more imaginative and you can understand what it's talking about. Anyway, okay. So we choose size and we choose node area. And for the attribute, we already calculated. So we choose current flow between the centrality. We can choose whether we want to include labels inside the node area, inside the size region, but we don't want. And unclick the auto scale, you can set up the minimum size, but the maximum size, I think it's already default by Visone, right? And so, and then choose it. You can draw the bar and decide the number, or you can fill it in and visualize. Now you see the graph changed. The larger node is, the larger is current flow between the centralities. And you can scroll your mouse to do in or do out. This kind of scales is similar as what you use in Gephi. So far, any questions?
This is actually similar to another question that I just typed an answer to, which is what's unique about Visone. Now, as I said a little bit earlier, that if we calculate between the centrality, for example, in Gephi, edge weight is not taken into consideration. Directions are not taken into consideration. So if a person is promoted from a governor's position to a member of the state council, and that is treated as exactly the same as a person who was in the state council, but then was demoted to a governor's position. So in Huei-Lan's network, directions matter. And edge weights also matter, right? So how many times do we see a person was promoted from a county magistrate directly into the state council? And that's going to be very rare, even though that happens. But it's probably much more frequently that we observe that people in the governor's position was promoted to were promoted to the state council. So edge weight also matters. So not taking directions of edges and weights of edges into the calculation between the centrality from Huei-Lan's point of view in her network is actually a problem. And we cannot deal with that problem in Gephi. Between the centrality based on the classical algorithm that was implemented in Gephi do not take either factor into consideration. Visone, for example, handles that with this new measure called the current flow between the centrality, which sort of current flow in the sense that you may imagine the flow of electricity, right, from one node to another. So that's why it sort of supplements Gephi. In general, no program does everything for network analysis or visualization. Gephi certainly far from does everything. Right? UCINet does a lot more, but still it's not everything. So it's very important that we use different programs and think about what are the problems behind a particular algorithm in that program, and whether these assumptions they're making, not taking into consideration edge weights or directions of edges, whether these assumptions are a problem for our research. Then we need to know how to export data from one program for analysis in another program, and then reintegrate the results into the original data set. So that's what we're trying to accomplish here.
Oh, I have a question. Is that mean main difference, or that's the minor difference?
Well, it depends on, like, from a historian's point of view, I think we use different programs for different purposes. I myself have not really used Visone very often. I didn't find the need to do so. I myself tend to rely very much on Gephi net draw and UCI net. But this is so far one of the differences that I discovered. There may be other differences, but I'm not sure.
Okay, so
there are also still other programs like Cytoscape is a strong network visualization tool,
Yes.
which is used in the bioinformatics very often. And they have very good output functions. So that's, for example, Gephi cannot output SVG in the current version very well, but Cytoscape can output your visualization as an SVG, which is sometimes helpful even for publication or so.
Good.
Now, following, we are going to export data from Visone and integrate that data back into Gephi. So what should we do now? So let's go to the toolbar on the top. And then you see Attribute Manager. Select Import and Export. And type in the file name you want to name it. And let's anyway, post. Anyway, so we give it in and select the location you want to save it. And do remember to choose the file name, the file extension as CSV, and OK. And forget. And we want to source the data by ID, and then we want to export current flow between the centrality, and we already choose the location, and then we export. So
doesn't matter.
Check whether these options are correct, and if anything, nothing wrong, then click OK. Then let's see the files we export. So we first open an Excel file. So you're supposed to see a file like this. So the same, you choose UTF-8 for origin, common for separator. And now we see current flow between the centrality, and the ID is the office name, office title, and it's that import. Now we have the figures for current flow centrality, and save it as a CSV file. And close it. We are going to move back to Gephi. Go to Data Laboratory and choose the Node tab. Click again, Import Spreadsheet. And the file we just export from Visone, open. So choose Common as separator and Node tab. This time we use Node tab, not Link tab table, and UTF-8 the same. Next. You see here ID, because Gephi automatically detect ID to match the source node in the system, already exists in the system. And then we have current flow between the centrality, and it's a float because it's not integrated. So we choose float and finish. Now it is a directed graph, so do choose directed, and do remember choose append to existing workspace and choose and click OK. So now you can see there's a current flow between centrality import into our nodes table. Let's keep moving. Okay, so you see we have this current flow between the centrality. We have modularity class. So let's move back to overview. Now we do what we already learned. We go to appearance and choose node tab and choose the size icon and ranking. Now we can see current flow between the centrality here. Choose it and set up the minimal and maximum that you think proper and apply. So you can see that there are some nodes become more visible than others because they host higher score of between current flow between the centrality. We can make a comparison. So go back to statistic and we can try to calculate between the centrality. Earlier we do in Visone, we do current flow between the centrality. Now in Gephi, we can do between the centrality. It is inside the network diameter, the third one. So run it. So again, it asks us whether it's directed link. Yes, and you can normalize it. That's for comparison, or just not click, it's fine. And just as Professor Chen already reminded us that even though you click directed, its direction is not considered in the betweenness centrality in Gephi. Okay, click. So okay, now then let's try to visualize betweenness centrality here. Apply. You see the nodes are changed. The most visible nodes are not the same anymore. If you want to compare the difference, Professor Chen mentioned earlier that there's a way to copy all the nodes to another workspace and do different kind of visualization for comparison. So can Professor Chen demonstrate that for us?
Oh, sure, of course. I'll be glad to. So in the interest of time, I'll be very quick about this. Let me share my screen first. So let me see. Share screen here. Now, so here is the network that I have for the appointments. So what I need to do is to go to, let me close this because I just did this earlier. So what I can do is that I can go to data laboratory, and there we have nodes and edges data tables. So I can pick the nodes table and use Control A to select all the nodes, and then right click and choose copy to, and then you can copy to a new workspace. And then we see workspace 5 because I did a number of other things later earlier. So you probably get workspace 2 or workspace 3. And then you go there, you have exactly the same data. You go to overview, you have exactly the same graphs. Now, basically, you have created 2 workspaces. So you think of your Gephi as your project folder. Under each project, you have multiple different workspaces, and you can save all of these workspaces in one single project file. Okay, so here under workspace 2, what I can do is that I'm going to size the nodes according to the ranking. Now here, I'm going to use between the centrality as the ranking and click apply and see what are the nodes are most important according to the between the centrality we have. Now, if we go to workspace 5, I'm going to do the same thing, and I'm going to choose current flow, which is the between the centrality, a modified version of between the centrality that is calculated in Visone that takes into consideration both edge weights and the direction of edges. And I'm going to click apply as well. And you can see that these nodes are different, right? So here, these are the most important nodes, but here, the distribution is different. Or we can try to see this same thing in one picture by changing not just the node sides. Remember here, the node sides are based on the between the centrality. And we can change the color of the nodes based on the current flow between the centrality, right? So then the highest ranked nodes will have darker colors according by current flow between the centrality. Now here, what we can try to see is the differences between the size of nodes and the color of the nodes. The darker the color, the higher the nodes current flow between the centrality. The bigger the size, the higher the score for the nodes normal sort of classical between the centrality. And in this node, for example, these two measures match. It has the darkest color and one of the largest sides. But in some of the other cases, it probably does not matter. In some cases, we probably see differences. Here, can I see? Now here, for example, you have a node that has a relatively small size, which indicates its between the centrality is fairly low, but it has a darker color, which means once we take into consideration the edge weights and the directions of the edges, this node actually has a higher score measured by its current flow between the centrality calculated in Visone. So I'm going to just stop here.
I think this is basically covers all we want to share today. And if you want to have more practice, then perhaps you can try to create a network and size the nodes, just like Professor Chen did, between centrality for size and current between centrality for colors, and compare which one, what's the difference between those one. So when you doing that, following Professor Chen will take floor to answer your question. And before I wrap up this workshop, one thing I want to say that don't worry about you cannot digest everything at one workshop. I personally learned Gephi for at least 4 times to know all the things I know now. So every time you will know something new and build on that, you can learn more in the future. So thank you everyone today.
Thank you very much. Thank you very much. I have one more question here so instead of typing the answer, I'll just answer live. The question is how to zoom in the nodes to see people's names. You can just place your, you may just place your mouse on the screen on the, in the appearance, in the overview tab. Place your mouse on the screen and then scroll your mouse to zoom in and zoom out. If you don't have a mouse, that's probably going to be a little bit tricky. I always recommend that people use their mouse when they are working with the Gephi.